China has landed a vehicle on the far side of the moon for the first time in history.
For thousands of years, we've looked up at the same moon, the same craters, the same dark spots, the same pale face staring back at us every single night. We thought we knew what the moon was: a dead rock, a dusty museum, a relic of the early solar system with nothing left to teach us. We were completely wrong. China just landed a robot on the side of the moon that never faces Earth, the side no human has ever touched, the side that's been hiding in cosmic shadow since before dinosaurs walked the planet. They drilled into ancient soil, scooped up rocks from the deepest scar in the solar system, and brought them back to Earth. And what scientists found in those 4 pounds of lunar dirt is rewriting everything we thought we knew. The moon doesn't have one face. It has 2 completely different personalities. One side is a volcanic graveyard flooded with ancient lava. The other is a pristine highland that never melted. One side is packed with radioactive heat. The other is frozen solid. And sitting in that hidden soil are wonder materials that shouldn't exist. Water hiding in plain sight. And enough energy to power human civilization for millennia. The far side wasn't empty. It was waiting for someone to finally listen. Here's what China discovered: the landing that shouldn't be possible. Let's start with why landing on the far side of the moon is considered impossible. The moon is tidally locked to Earth. That means it rotates at exactly the same speed it orbits. One face always points toward us. The other face always points away. Always. The far side isn't dark. It gets just as much sunlight as the near side, but it is permanently hidden from Earth's view. And that creates a massive engineering problem. Radio waves travel in straight lines. They don't bend around corners. They can't pass through solid rock. So when you send a spacecraft to the far side of the moon itself blocks every signal. Total radio silence. You can't communicate with your robot. You can't steer it. You can't tell it where to land or what to do. It's like trying to drive a car while blindfolded with your hands tied behind your back. That's why NASA never attempted a far side landing during Apollo. The Soviet Union tried and failed. Every space agency in the world looked at the problem and said, "Not worth the risk." Until China said, "Watch this." In 2018, China launched a satellite called Queqiao. The name means magpie bridge, from an ancient Chinese legend about lovers separated by the Milky Way who could only meet once a year when magpies formed a bridge across the stars. Poetic, but also brilliant engineering. They parked this satellite in what's called a halo orbit around the Earth-Moon L2 point. This is a gravitational sweet spot where the pull of Earth and the moon balance out. The satellite doesn't orbit Earth. It doesn't orbit the moon. It hovers in a stable position using almost no fuel, like a beach ball floating between 2 fans. From this position, one side of the satellite can see Earth. The other side can see the far side of the moon. It acts as a relay, bouncing radio signals over the moon's shoulder like a mirror in space. Suddenly, the communication blackout was solved. The bridge was built. With Queqiao in place, China launched Chang'e 6 on May 3, 2024. The target was the South Pole Aitken Basin, not just any crater, the largest, deepest, oldest impact scar on the moon, about 1,500 miles wide and 5 miles deep. The impact that created this basin nearly cracked the moon in half over 4 billion years ago. On June 2, 2024, Chang'e 6 began its descent, and for 15 terrifying minutes, Earth couldn't help. The signal delay was too long. Commands sent from mission control would arrive too late to matter. The lander was completely on its own, falling toward a surface no machine had ever touched, dodging boulders the size of houses and craters deep enough to swallow a skyscraper. But Chang'e 6 didn't have a human pilot. It had artificial intelligence. Onboard cameras scanned the terrain in real time, comparing live images with hazard maps. Every second, the AI recalculated thrust, adjusted angle, rejected unsafe zones, all while fuel burned away and gravity pulled harder. The final moments were the most dangerous. Dust kicked up by the descent engine's blinded sensors. Low lunar gravity made every movement unpredictable. One wrong bounce and the mission would end in a twisted pile of metal at the bottom of the oldest hole in the solar system. But the AI held steady. The legs touched down. Contact confirmed. Chang'e 6 had stuck the landing in the most difficult environment humans had ever attempted. And what happened next changed everything we thought we knew about the moon. The mystery of 2 completely different worlds. Look up at the full moon tonight and you'll see dark patches scattered across its face. Ancient astronomers called them Maria. Latin for seas, because they thought they were oceans. They're not. They're frozen lava plains. Billions of years ago, massive volcanoes erupted on the near side of the moon and flooded enormous regions with molten basalt. The lava cooled into smooth, dark rock. Those are the shadows you see when you look up. Now here's where it gets strange. The far side of the moon has almost no dark spots. It's bright, rugged, and covered in craters stacked on top of craters like a battlefield frozen in time. No lava floods, no volcanic seas, just ancient, battered highlands that look like they've been hammered by asteroids for eons. Both sides of the moon are exposed to the same space environment, same meteorite bombardment, same temperature extremes, same lack of atmosphere. So why did one side melt into volcanic plains while the other stayed a frozen wasteland? This is called the lunar dichotomy, and it's been one of the biggest unsolved mysteries in planetary science for over 50 years. Scientists had theories, sure, computer models, educated guesses, but no proof, no way to test the ideas because nobody had ever brought back rocks from the far side. Until now, when Chinese scientists opened the Chang'e 6 sample container, the first thing they noticed was the color. The soil wasn't the pale gray dust that Apollo astronauts brought back. It was darker, richer, different. Under the microscope, the chemistry told a shocking story. The key is a group of elements scientists call creep. That stands for potassium, rare earth elements, and phosphorus. These aren't just random chemicals. Many of them are radioactive, and radioactive elements produce heat. A lot of heat, for billions of years. Think of creep like a planetary heating blanket buried under the surface. When Apollo astronauts brought back rocks from the near side in the 1960s and 70s, those samples were packed with creep. The near side was hot on the inside, cooked from below by radioactive decay. But the Chang'e 6 samples from the far side? Almost no creep. Clean, cold, frozen. This confirms something wild that scientists suspected but couldn't prove. The moon is lopsided on the inside. When the moon was forming billions of years ago, somehow all the radioactive elements concentrated on one hemisphere. The near side facing Earth got the heat. The far side got left out in the cold. That internal heat made all the difference. The near side crust got cooked and thinned out over time. With a thinner crust, magma from deep below could punch through to the surface. Volcanoes erupted for billions of years, flooding the lowlands with wave after wave of lava. That's why we see those dark maria when we look up at night. The far side, without that internal furnace, cooled down fast. It developed a crust that's roughly 20 kilometers thicker than the near side, and that thick crust acted like a lid. The magma couldn't break through, so while the near side glowed with rivers of molten rock, the far side stayed a cold, bright highland. NASA estimates the near side mantle was about 100 to 200 degrees Celsius warmer than the far side. That might not sound like much, but over billions of years, that temperature difference created two completely different geological personalities fused into one body. The moon isn't one world, it's two worlds glued together, one half shaped by fire, the other shaped by silence and time. The wonder material hiding in moon dust. But chemistry was only the beginning, because what scientists found next shouldn't exist in nature at all. Imagine taking a pencil. The graphite inside is just layers of carbon atoms stacked on top of each other like a deck of cards. Now imagine peeling off a single atomic layer with a piece of tape. That impossibly thin sheet, just one atom thick, is called graphene. Graphene is a miracle material. It's 200 times stronger than steel but lighter than paper. It conducts electricity better than copper. It's transparent, flexible, nearly impenetrable. On Earth, we make it in high-tech laboratories using lasers, chemical vapor deposition, and extreme precision. It doesn't just form naturally lying around in the dirt. Or so we thought. Chinese scientists analyzed the Chang'e 6 soil under powerful electron microscopes and found natural graphene flakes scattered throughout the lunar dust. These weren't random carbon smudges. They were perfectly formed sheets, just 2 to 7 atoms thick, with the exact hexagonal structure that makes graphene so extraordinary. How does a high-tech wonder material end up forming naturally on a dead rock in space? The answer is violence. The moon has no atmosphere, no magnetic field, no protection from the cosmic firing range. For 4 billion years, it's been bombarded by meteorites traveling at tens of thousands of miles per hour, some the size of grains of sand, others the size of city buses. When these projectiles slam into the lunar surface, they deliver unimaginable pressure and heat for a split second. That impact shock compresses carbon molecules in the soil instantly, squeezing them into perfect atomic lattices. The temperature spikes to thousands of degrees, then crashes back down in microseconds. The structure gets locked in place before it can break apart. It's not a careful laboratory process. It's a cosmic hammer strike. The moon is essentially a giant factory, using asteroid impacts as tools to manufacture graphene from raw carbon in the dirt. And this matters more than you might think. If we ever build a permanent base on the moon, we can't ship every construction material from Earth. Launch costs are astronomical. Every kilogram of cargo costs tens of thousands of dollars to send to lunar orbit. But if graphene exists naturally in lunar soil, we don't need to ship it. We can harvest it, process it, use it on site. Super strong composites for habitat walls, conductive materials for electronics, protective coatings for equipment, lightweight structural components, all sitting right there in the dirt, waiting to be refined. The lunar surface isn't just worthless dust, it's a hardware store, a supply depot, a resource waiting to be tapped. The ancient ocean of fire. But graphene wasn't the only discovery that rewrote the textbooks. Chang'e 6 also confirmed the most violent chapter in the moon's childhood. About 4.5 billion years ago, when Earth was still a molten infant, a Mars-sized planet called Theia smashed into us in a catastrophic collision. The impact was so violent it vaporized entire continents, blasted enormous chunks of Earth's mantle into orbit, and nearly shattered both worlds. Those ejected chunks, glowing red-hot and spinning through space, eventually clumped together under their own gravity. That debris cloud became the moon. If this theory is true, and most planetary scientists believe it is, then the newborn moon wasn't a solid rock. It was entirely liquid, a glowing ball of molten lava floating in orbit, radiating enough heat to turn nearby space into a furnace. This is called the lunar magma ocean hypothesis, and it predicts something very specific. As the moon slowly cooled over millions of years, crystals would begin forming in the molten soup. Heavy minerals like iron and magnesium would sink toward the core. Light minerals like aluminum and calcium would float to the surface like foam on boiling water. And those floating crystals would eventually freeze into the moon's first crust. Until now, this was just a theory based on computer simulations and indirect evidence. But Chang'e 6 proved it. The samples contain high concentrations of anorthosite, a light-colored rock made mostly of plagioclase feldspar, aluminum and calcium minerals. Anorthosite can only form one way: by floating to the top of a global ocean of magma and cooling there. You can't make it through volcanic eruptions or meteorite impacts. It requires a planet-wide melt. This confirms that the entire moon was once a single, sloshing ocean of lava stretching from pole to pole. The moon isn't a captured asteroid that wandered too close to Earth. It's the child of violence, made from pieces of our own planet that were melted, reformed, and locked into orbit. And because the South Pole Aitken Basin is so incredibly deep, 5 miles down, the impact that created it punched straight through the crust and exposed the mantle, the deep rocky interior of the moon that normally stays hidden. On Earth, we've never been able to drill down to the mantle. The deepest borehole ever made, the Kola superdeep borehole in Russia, only reached about 7.5 miles before the drill bit melted. Earth's crust is just too thick. But on the moon, a massive asteroid 4 billion years ago did the drilling for us. The Chang'e 6 samples contain minerals like pyroxene and olivine, heavy, greenish crystals that belong deep underground in the mantle. Finding them sitting on the surface is like finding diamond rings washed up on a beach. They shouldn't be there, but they are, because the impact that created South Pole Aitken dragged them up from the depths and scattered them across the basin floor. This gives scientists the first ever direct look at the interior of another world. We're not just looking at the moon's skin anymore, we're looking at its organs. The water that shouldn't exist. For decades, scientists taught us that the moon was bone dry, drier than the driest desert on Earth. Apollo astronauts brought back rocks that contained less moisture than volcanic ash. No water, no ice, nothing. But China's missions shattered that certainty. In the Chang'e 6 samples, scientists found hydrated minerals, not ice hiding in a permanently shadowed crater, not frost on a cold surface, but water molecules chemically bonded inside rocks sitting in direct sunlight. One newly discovered mineral, A hydrated salt with the formula nitrogen tetrahydride magnesium chloride 6H2O contains about 41% water by weight. That's not a trace amount. That's a significant reservoir locked inside a crystal structure. Where did it come from? Meteorites. For billions of years, the moon has been pelted by carbonaceous chondrites, primitive space rocks rich in water and organic compounds. When these meteorites slam into the surface, they don't bounce off, they shatter, mix, become part of the soil. With no wind, no rain, no erosion to wash them away, those fragments are still there, scattered throughout the lunar regolith, pieces of the early solar system frozen in time. This changes everything. If water is locked in minerals across the lunar surface, we don't need to find rare ice deposits in permanently shadowed craters. We can extract water anywhere. Just heat the rocks and collect the steam. The moon isn't a desert. It's a sponge that's been soaking up water for 4 billion years. But water isn't just in minerals. It's also in glass. When meteorites hit the moon, the impact melts rock instantly. Droplets of molten material spray outward, cool in mid-flight, and fall back to the surface as tiny glass beads. The lunar soil is full of them, billions upon billions of microscopic glass spheres. And these beads are packed with water. The sun constantly bombards the moon with solar wind, a stream of hydrogen atoms. That hydrogen hits the glass beads, bonds with oxygen in the silica, and forms water. The glass acts like a storage tank, trapping molecules inside its structure. Scientists estimate these impact glass beads alone could hold about 270 trillion kilograms of water across the lunar surface. That's enough to fill a small lake. And it's ridiculously easy to extract. Just heat the beads in a simple oven and the water steams out. No complex chemistry required. We don't need to haul millions of gallons of water from Earth. We just need a vacuum cleaner, a microwave, and a collection system. The barrier to lunar settlement just dropped dramatically. The energy jackpot sitting in the dirt, but there's something else in that soil, something worth trillions of dollars. Helium-3. Most people have never heard of it, but physicists dream about it. Helium-3 is a rare isotope, a version of helium with one less neutron than normal. It's almost non-existent on Earth because our magnetic field blocks it, but the moon's been soaking it up from the solar wind for 4 billion years with no magnetic field to stop it. Why does this matter? Because helium-3 could power nuclear fusion reactors without producing radioactive waste. Clean energy, limitless energy, the kind of energy that could replace fossil fuels, eliminate carbon emissions, and power human civilization for millennia. Right now, we don't have working fusion reactors. The technology is still experimental. But when we figure it out, helium-3 becomes the most valuable substance in the solar system. And the moon is covered in it. Scientists estimate that 100 tons of helium-3 could power the entire planet for a year. The moon has roughly 1 million ton. That's 10,000 years of energy sitting in the dirt. In the Chang'e 6 samples, Chinese scientists discovered a new mineral called changesite Y. It's a transparent crystal containing trace amounts of helium-3. This is only the 6th new lunar mineral ever discovered by humanity, and the first found by China. China hasn't been shy about their interest in lunar mining. They've publicly stated that resource extraction is a long-term goal. They're not just there for science. They're mapping the moon like prospectors mapping a gold rush frontier. And if the economics work out, if we develop efficient fusion reactors and cost-effective mining operations, the moon becomes the most valuable real estate in the solar system. The race nobody's talking about. So what is China planning to do with all this knowledge? They're not just publishing research papers. They're building infrastructure. China has announced the International Lunar Research Station, ILRS, a plan to construct a permanent base on the moon's south pole by the 2030s. Not a small outpost. A real settlement where astronauts can live and work for months at a time. And they're not going alone. Russia has signed on. The United Arab Emirates has expressed interest. Pakistan, Venezuela, South Africa, and others are in discussions. While NASA focuses on landing astronauts with the Artemis program, China is focused on sustainability, figuring out how to extract water from soil, how to manufacture building materials on site, how to generate power without shipping fuel from Earth. By landing on the far side, China proved they can operate in the most difficult, isolated, and dangerous environments on the moon. This wasn't a publicity stunt. It was a survey mission. They were checking out the backyard to see if it's worth building there. The answer appears to be yes. But China isn't the only one eyeing prime lunar real estate. NASA has identified 13 potential landing sites for Artemis 3, which plans to land astronauts sometime in the late 2020s. And when you compare NASA's target zones with China's survey sites, they're almost identical. Specifically, everyone wants Shackleton Crater. Why? Because it's perfect. Shackleton sits right at the South Pole. It has high ridges that receive near constant sunlight, ideal for solar panels. And it has deep valleys that are permanently shadowed and potentially filled with massive deposits of water ice. It's the ultimate piece of lunar real estate, like finding an oasis in the middle of the Sahara. Whoever controls that oasis controls access to the entire desert. China plans to launch Chang'e 7 in 2026 and Chang'e 8 in 2028 to survey the South Pole in detail and test resource extraction technologies. NASA plans to land astronauts around the same timeframe. We're heading for a cosmic traffic jam. Unlike the space race of the 1960s, where countries planted flags, took photos, and went home, this time we're building houses, and there are only a few good spots to build. The moon is no longer a symbolic destination, it's strategic territory. What this all means: the moon is not what we thought it was. For decades, we treated it like a dusty attic. We climbed up, looked around, grabbed a few souvenirs, and left. We assumed both sides were the same. We assumed it was dead, useless, a relic with nothing left to offer. But China opened the windows and let the light in. They found a world of duality, fire and ice, a lopsided interior that created two completely different geological personalities. They found wonder materials like graphene forming naturally from cosmic violence. They found water hiding in rocks and glass across the entire surface. They found energy reserves that could power civilization for millennia. And most importantly, they found that the far side isn't just a boring reflection of the near side. It's a completely different animal with its own history, its own secrets, its own untapped potential. The moon is useful, not just a rock to admire, but a factory, a mine, a gas station, a construction yard floating in permanent orbit 240,000 miles away. The space race is back, but this time, the finish line isn't a flag planted in the dust. It's infrastructure, settlements, industry, permanent human presence beyond Earth. And right now, China has the best samples, the best data, and the clearest roadmap. The hidden face of the moon has finally been revealed, and it's more valuable than anyone imagined. So what do you think? Should we mine the moon for resources, or leave it untouched? Could graphene harvested from lunar dust become the backbone of permanent settlements? And what happens when two superpowers compete for the same crater? Drop your thoughts in the comments. And if you want to follow this story as it unfolds, because it's just getting started, hit subscribe and turn on notifications. The next mission launches in 2026, and what we find could change everything. Thanks for watching. We'll see you on the next